Hey Math 6 and happy Wednesday. Are you ready for class with that charged Chromebook? And math binder and pencil should be nearby. We are continuing on in our study of 2D figures, and today and tomorrow we're going to focus on properties of quadrilaterals. So, what is a quadrilateral? When we think of quadrilaterals, and when we see the word even, I want you to look at the prefix here, quad. The prefix quad quite literally means four. So when we think of a quadrilateral, our brain should connect the prefix quad, four, to our study of shapes. So a quadrilateral is any four-sided closed shape. So you might be thinking to yourself right now some quadrilaterals that you already know. A square is a quadrilateral. A rectangle is a quadrilateral. A rhombus, a parallelogram, a trapezoid. So you're very familiar with four-sided shapes, and in their most general of terms, we can call any four-sided shape a quadrilateral. I'm sitting at my little makeshift desk for distance learning right now, and I'm looking around and I see quadrilaterals everywhere. I have my phone case, my planner, my whiteboard, my computer screen. I have this little white energy light next to me. I don't know if you guys can see it. There you go. It is also a quadrilateral. My dry erase board eraser is a quadrilateral. A picture frame is a quadrilateral. The cork board that I hang my necklaces on is a quadrilateral. They are literally everywhere in our daily lives. We learned about triangles earlier in the week, and one of our biggest takeaways from triangles is that their interior angles add up to, do you remember? 180 degrees. So if we think of any quadrilateral, they can actually be split into two triangles. So here we have a trapezoid, and it's split in half to make two triangles. Another example of a trapezoid, or when you were younger and when I was younger, sometimes we heard these called a kite or a diamond. So these are also split in half and make two triangles. So any quadrilateral can be split in half to make two triangles. So if we add up 180 degrees of one triangle and 180 degrees of the other triangle, all together we get 360. So the measures of all four angles inside of a quadrilateral should add up to 360 or have a sum to 360 degrees. That is what is important to know about interior angles. We're going to take a look at 5 more specific types of quadrilaterals and their characteristics. Again, it might be helpful to have your math binder nearby. You might want to jot down that all angles in a quadrilateral add up to 360 degrees. The first type of quadrilateral we're going to talk about is a trapezoid. So a trapezoid is a quadrilateral with only one pair of parallel sides. We studied types of lines, so you know what parallel mean. Parallel lines are the same distance apart always, and they go on forever and ever and ever, but they never touch, they never even get closer to each other, and they never get further away from each other either. They stay the same distance apart. So I'm looking at this picture up here of my trapezoid, and I see one pair of parallel lines. The top and the bottom are parallel. So that's what makes this quadrilateral a trapezoid. It only has one pair of parallel lines. Notice the right and the left sides. If they were to go on forever and ever and ever, they would cross eventually at the top. Other types of quadrilaterals, let me move my face out of the way here, that we have are parallelograms and a rhombus. So here's a picture of a parallelogram. A parallelogram is a quadrilateral with both pairs of opposite sides parallel. So the top and the bottom are opposite. They're parallel. They're never going to touch. And the left and the right sides are also parallel. They are never going to touch. They're both slanted just a little bit, so they'll go on forever and ever and ever without touching. Not only are opposite sides parallel, but opposite sides are also congruent. Think back to what you know about that word congruent, just a fancy math word that means the same or equal. You should be familiar with these little tick marks by now as well. One tick on either side shows that they are congruent, that they're equal, they're the same length. Two tick marks over here shows that those two sides, the right and the left, are also congruent. They're the same length. A parallelogram has one more important characteristic. Opposite angles are also the same. So you'll notice here we have an obtuse angle, and its opposite is also an obtuse angle. And if we knew the exact measurement, they would also be the same. So if this was 100, this would also be 100 degrees. You'll notice these two angles are opposite, and they're also congruent. Do you notice how there's two lines here showing where the angle is and two lines here? That shows that they're congruent. One line for the angle, one line for the angle shows their congruence. It's a lot of characteristics for one shape. A rhombus is in the parallelogram family, which is in the quadrilateral family. And a rhombus is just a parallelogram with all sides congruent. So both sides, opposite sides, are parallel, and all sides are the same length. Opposite angles are congruent. It almost looks like if you took a square, because a square also has all four sides that are congruent, and you just tilted it a little bit. All right, here we have some classic quadrilaterals. We have a rectangle, which is a parallelogram with four right angles. It's a parallelogram because opposite sides are congruent. They're the same length. Opposite angles are also congruent. But you'll notice that all angles are actually the same here. They're all right angles. And then we have a square. A square is actually a type of rectangle. It's in the rectangle family, which is in the parallelogram family, which is in the quadrilateral family. They're all connected, almost in like one messy web. A square is a rectangle with all sides congruent. It's also a rhombus. If we click back to a rhombus, we can see why it would be a square. All sides are congruent, and opposite angles are congruent. Let's look at the square. All sides are congruent, and opposite angles are congruent. So you can see there's a lot of crossover between these shapes, and a lot of them belong in like different families or different groups. But it's no different than you and I. We kind of fall into different groups ourselves. I fall into like a middle school teachers group. I fall into an elementary school teacher group. I fall into the bigger West teachers group. I fall into a group of elementary homeroom teachers because I used to teach 4th grade to many of you. So just like I'm one person, I can be classified in a lot of different groups at West. Our shapes are all unique, but they can be classified under multiple headings like quadrilaterals or parallelograms. We're going to practice identifying some shapes and also finding their angles. Look here at the directions. It says classify each polygon in as many ways as possible. Find the missing angle measurement. So if I wanted to classify the polygon for number 1, I'm going to kind of think out loud for this one. I can see that there are 4 sides, so it would be a quadrilateral. And I see that there's one pair on the right and the left of parallel sides. And if I go back in my notes, I know that is a trapezoid, a quadrilateral with one pair of parallel sides. So I would say for this first one that it's a quadrilateral and a trapezoid. So I classified it in two ways. The missing degrees here, I need to remember that the interior angles of a quadrilateral add up to 360 degrees. You're also going to need to know what these boxes mean in the corner. Do you remember? That symbolizes that it's a right angle. So I would need to add 50 plus 90 plus 90 plus what? X equals 360. Go ahead and pause and try that one now. See if you can figure out what the missing angle is equal to. All right, are you feeling good about it? Did you get 130 degrees? Awesome. You can check your answer by plugging it back in. So you could do 90 plus 90 is 180. And then if you had 50 and 180, and if we added those together plus 130, we would have a total of 360. Let's try one more together. Let's take a look at number 2. All right, looks like there's 4 sides, so it's definitely a quadrilateral. I'm noticing that opposite sides are congruent and parallel, and opposite sides are congruent and parallel. I'm going to go back in my notes and check. Okay, here I see opposite sides are congruent, opposite angles are congruent, but all the sides aren't equal. So that makes me think that it's a parallelogram. And again, I can figure out what that missing amount is by adding them up, but I also know something else about parallelograms. So if I can identify this as a parallelogram, if I can classify it as a parallelogram, I actually don't have to do any adding or subtracting to figure out what the missing angle is. I can look and see that opposite angles are congruent. So if those are both 120, what do you think this is going to be? Yeah, it's going to be 60. Opposite angles are congruent. You're going to try 3 and 4 in addition to some other problems on today's assignment. So today is going to be some practice on classifying quadrilaterals, and tomorrow will also be some work on quadrilaterals. Please use your notes when you're doing any of this work and answering any of these questions. You can always feel free to watch the YouTube videos over again, pause them, take screenshots, set yourself up for success here, guys. You have a lot of tools at your fingertips, and everything is here to help you. I'm looking forward to seeing you tomorrow, Thursday at 11 o'clock at our Google Meet as per usual. And I hope you guys have an awesome rest of your day, and please email me with any questions if you just want to say hi, or if you want to send me a funny math meme, because I'm almost out. All right, I'll see you guys later. Bye.